Welcome to the NADCA show 2018. I'm now going to talk about Dievar and why Dievar is so good in the area of high pressure die casting, and particularly in the biggest failure of heat checking or thermal fatigue. So Dievar has many properties which come together to make the product so good in this area. For instance, its chemistry and also how it's made, ESR process. These come together to make a great tool steel with all the properties needed to fight heat checking, which is the biggest failure in high pressure die casting globally. So the biggest growth we're seeing at the moment is in the area of structural parts. So before we used to do lots of engine castings, but now we're seeing big growth in structural parts of the car, which traditionally would have been pressed in cold steel. Now this is presenting many challenges for high pressure die casters, because these parts have to be high quality. If the car is involved in a crash, for instance, it can't have any surface defects on it, or heat checking, thermal fatigue, because these small cracks could propagate when a car crashes, and obviously the part isn't then going to work properly. So this is a problem that many of the casters now have to deal with, is this thermal fatigue or heat checking is the main issue. But also the die life is getting worse as well, because often these parts are pushed, they push the machines to their limits, the die life tends to go down, not up. So with reduced die life, this is also a problem. And also the market is growing, so if you only have a couple of high pressure die casting machines, you need to make them more efficient, which means you can't really be changing dies all the time to do repairs. So what's the answer? Well, not to do what you did before, that's for sure. You need to change things. Now, what you did before was a steel called H13, which we see here on the slide in front of you. We also see the chemistry of Dievar, and here we can see the real difference between the two tool steels. Subtly, if you just looked at it, you might think they're quite similar, but in fact they're very different. The Dievar, for instance, has more molybdenum in it, which is a great element for adding great properties in the environment of high pressure die casting, which H13 does not have. Also, Dievar is a unique grade, so although it's in NADCA as a 2367 modified, in fact it's got its own patent. It's a unique tool steel. So Dievar has many properties, not only just with the thermal fatigue and heat checking resistance, it's also extremely tough. In fact, it's tougher than an H13 at the same hardness. So a big benefit to Dievar is if you have a big die and you need to get a better thermal fatigue or heat checking resistance, then you can raise the hardness in the Dievar as well. Obviously you have to consider the die design and if there's any history of cracking in the tool, but this is a big advantage to Dievar. So compared to H13, if it's the same hardness, Dievar should always be tougher. This is of course a very important property when the dies get big. So if your structural part is now bigger and you can't maybe have what's called split lines on it because of the crash issue as well. A split line would be a stress raiser, which again would initiate a crack if the car crashed. You have to have a big insert, and we've perfected at Uddeholm Dievar being made into really big sizes. In fact, some of the biggest we've made to date are 18 tons in weight, which is massive. But what's really interesting is the great quality that's still in the center of the tool is extremely high. In fact, some Dievar has been tested to over 20 foot-pounds of impact energy in the center of these big blocks. Here we can see the real reason why Dievar is so good compared to an H13. On the screen here you see basically at the same hardness, over time they temper back. And again we see Dievar is extremely different here to H13. It takes much longer to temper back. It maintains its hardness for longer, which means thermal fatigue is delayed, which means your die will make more parts. And again, now we see some historic testing of Dievar, which shows again how its thermal fatigue resistance is far superior to H13. On the lower line, you see Dievar, and on the upper line, you see a premium H13, all tested at the same hardness. And if we take the normal hardness of about 44 Rockwell, you'll see that Dievar has about 30 microns crack depth, and H13 ESR has about 105, 110. This is a huge difference in crack depth in heat checking. And here we have a case study from a customer, which just goes to show in application how Dievar really performs superior to an H13. Here we see both dies are the same hardness. They've both run 95,000 shots in the machines. And the H13 die is heat checking as a failure, which you can clearly see on the top right hand side. And Dievar below it has nothing at all. That's the benefit of using Uddeholm Dievar. My name is Richard Oliver, and thank you very much for listening to me about Uddeholm Dievar.